Okay, this is passage 2. It's a conflicts passage. We know it's conflicts because it says student 1, student 2, student 3, student 4. Conflicts passages will usually say student or scientist. Sometimes it might say method or hypothesis, but usually student or scientist. In our DRC approach, C stands for conflicts and carefully read. This is the one passage that I think is a little bit reading heavy, and it benefits students to do a little closer reading of this one than other passages. So we'll talk about in the intro section where you should fit conflicts in your personal testing strategy. For the approach to the questions, we're doing the R and R approach. Quick read through the question and then break it down step by step in the reread. Step 1 is to identify the conflict, which is in the first paragraph. It's made a little bit bigger here, and it says 4 students each predict the function of root nodules and the effect of the bacteria on soybeans. It's about soybean root nodules and bacteria. So we're looking at function and effect is the main conflict. Step 2 is going to be to identify the differences each student takes. So let's break those down. Student 1, remember looking for function and effect, says the function of root nodules is to house the bacteria, and as the effect is, the plants will grow larger when the bacteria are present. So in general, house the bacteria, and the effect is makes bacteria larger. Let's break this down a little bit more, and I like to draw pictures. I find pictures helps me to understand these. So root nodules form only when bacteria are present. So I know they're housing, so I drew a circle and I put a little check mark with my little squiggly bacteria. The bacteria convert nitrogen in the atmosphere to ammonia, which is used as nutrients. So I put nitrogen, they convert it to ammonia, drew a little arrow, so it's kind of moving inside the house. That's student 1. Student 2, looking for the same thing, function and effect. The function is to house the bacteria. That's the same as student 1. The plants will grow larger. That's also the same as student 1. So student 1 and student 2 have the same function effect. So the difference has to be in the uses. So root nodules form regardless of whether bacteria are present. Okay, that's different. So I'll put a check mark and a little omit mark. They do also convert into the NH3, so that's the same. So really the only difference in 1 and 2 is bacteria don't have to be present for root nodules to form. We'll get to student 3. The function is to protect the plants, and the plants will grow larger if bacteria are absent. So no bacteria equals larger plants. Root nodules only form when bacteria are present, same as student 1. If bacteria infect the roots, nodules grow around the bacteria to keep it from spreading. So the nodules grow around it, they keep it contained. So I just drew circles around my bacteria. In student 4, the function is to protect the plants, same thing as student 3. And the bacteria are harmful, so the plants will grow larger when bacteria are absent. That is also the same as student 3. So student 1 and 2 were the same. Student 3 and 4 were the same as far as function and effect. So the differences is what happens. Root nodules form regardless of whether the bacteria are present. That was the same as student 2. And they transport the bacteria to root nodules, so they move it to a root nodule as opposed to protecting it. So you have a basic understanding of what's going on. I don't have a deep understanding of this. I couldn't explain the scientific process, but I can show what I read. And that's what matters. Now this passage also has an experiment that's actually kind of unusual in a science conflict. So we're going to skim. So we're just going to quickly skim this. 200 identical pots in a sterile soil. Bacteria were added to half the pots. They were placed in a greenhouse, looks for 45 days. Then they're looking at average root nodules, no bacteria. Average plant mass, no bacteria. Looks already interesting that root nodules are needed back to only form if there's bacteria present. So just notice that. All right, go to the question. Here's our quick summary of what we did. So let's get to question number 7. Students 2 and 4 both indicate. So we're going to have student 2 and 4. We're only using those two. That root nodules, well, it says they form regardless of whether bacteria is present. So we do the little check mark and omit mark, check and omit, or you can get it straight from the reading, which works for you. So they form whether the bacteria are present or not. So B. Number 8 is a suppose if why question. We're going to have to extrapolate or extend information. Additional studies showed that if bacteria were present, soybean plants required less fertilizer to reach their maximum size. Which students would agree with this prediction? So we know in students 1 and 2, bacteria equals larger plants. So it should be students 1 and 2, and students 3 and 4 says no bacteria equals larger. So it would be students 1 and 2 only. G. Number 9, how do the students ensure the bacteria were present in only half the pots? So this one's asking us to really go to the experiment. So it says they filled 200 pots with sterile soil, right? So sterile soil, they're not using non-sterile soil, so C and D are out. And to half the pots, they added bacteria. So half of 200 is 100, so your answer is A. Number 10, we have to use experiment and the student hypotheses both. The results for average dry mass more consistent with prediction of student 2 or 3. So student 2 says bacteria present, they grow large. Student 3 says no bacteria, they grow large. This is from the reading, right? Last sentence. Now, we can eliminate choices G and H simply because they don't support what the reading says. Right? We don't have to extend our knowledge at all because choice G says they would grow large when bacteria were absent for student 2, and that's not what student 2 says. Student 3 says the opposite of what is stated also. So now let's look at the chart. It says with bacteria, there is more dry mass, which means the plant is growing larger. So that means it would agree with student 2, F. Number 11, consider the 2 organisms discussed in the passage. So we discussed soybeans and bacteria. Which of the students, if any, indicate that the prokaryote harms the eukaryote? So I think I said those right. So we're going to go to the reading, and student 3 and 4 both mention the bacteria being harmful. Nothing in student 1 or 2 talks about harm. So I'm going to go ahead and eliminate student 1. So A and B I'm going to say is probably out. If nothing else, if I'm having to guess, I'm saying C or D would be the answer. And I'm probably going to guess C because it mentions harm in particular. But to get this right for sure, you have to have knowledge. Plants are eukaryote, bacteria is prokaryote. And so it says the prokaryote, the bacteria, are harmful to the plants. The prokaryote are harmful to the eukaryote, so the answer would be C. Number 12, before the experiment, which of students 1 and 4, so student 1, student 4, if either, would have been likely to predict the average plant dry mass, so the growth, would be the same for the plants grown in the presence of bacteria and the absence of bacteria. So student 1 said, if they have bacteria, the plants will be larger. So that means if they don't have bacteria, they will be smaller. So student 1 is out. Student 4 says, if they don't have bacteria, they're larger. So bacteria would mean not larger, right? No bacteria equals larger. Bacteria equals smaller. So student 4 is out. So the answer has to be neither student 1 nor student 4 would agree that plants that have bacteria or no bacteria would be the same size. So the answer is J. Number 13, how many of the students, if any, stated that bacteria must produce nitrogen to infect a plant's roots? So we see for sure that students 1 and 2 mention nitrogen. Students 3 and 4 don't mention it at all. So we're going to eliminate choices C and D because they don't even talk about nitrogen. But now this is interesting. They say student 1 and student 2 say they convert nitrogen, but convert is not produce. So none of them say they must produce nitrogen. So your answer is A. Double check the recording categories to see if there's anything that throws you off. These are all but one evaluation of models. or scientific investigation. So these are all questions where you have to extend your knowledge a little bit. There's no interpretation of data in this one. So reach out if you have any questions, and we'll end with our silly joke. What's a tree's least favorite month? I'm already giggling at this one. September. All right, have a good day.